maybe if
Alright, the live streaming.
This will be the worst if we move here.
you always see Sajana posting.
Is that the works?
Just starting this week.
Yeah, we just started buying stuff.
Today she already buying furniture. I
Yeah,
follow her.
we are buying furniture now.
That means you're moving in a few weeks now.
No.
Buying furniture later.
No, we asked them to deliver it like in 2 months.
Oh, so she took photo from the shop lah.
Yeah, end of August. Don't follow her, right? She's a bit.
What?
Sidarian
Say.
She's a bit Sidarian.
What do you mean by Sidarian? I'm also Sidarian. What?
Yeah, it's streaming up.
Oh no! Come!
What?
Let Sajana hear it all.
Complaint session.
Well, I tell you, never marry a Sidarian.
Hey. What? You and Fazli what? Brother.
Yeah. Sidarians are the most challenging.
Hey, you said already what? Update 9 hours ago.
Okay, can.
Do again.
So it's 25 on meetup.com and 44 on Facebook.
Shit.
But I think there's some overlap. Some people,
Like Rick Bell is not coming.
yeah, fake.
He's in what? Hong Kong, right?
No, because he's organizer, so they automatically. Going? Oh, I'm not going. Yes, I'm going.
Oh, you're going.
Am I going?
Just me.
Hey,
plus me.
Twitter, anything else? You said there's a bunch of. I'll time for you. You said there's a bunch of announcements you want to do after.
Well, I would like to do it every Hackware.
Yes, but can you start today?
Yes, hiring available for hire.
Yes.
And related hardware.
And there is an
Yes.
Right?
announcement from the venue. They requested us not to venue because Hackerspace was getting too crowded, and we would be like 5 people. No, not 5 people, but like not as many.
No, this is
7-Eleven, the time now.
Don't worry. This is better. It's harder to get to Hackerspace than here.
Yeah, but it's 7-Eleven and there's that.
Now people are punctual. They come at 7:30 on the
I
dot.
hope so.
There's also a huge crowd.
Yeah, that's
Yeah.
the
It's
design.
difficult to get through to.
Yeah. When people are stuck.
We had to, it took me a while to figure out this stairs.
Yeah.
So is Andreas?
Speaking or not? No.
If he comes, so that's why I moved stuff around. So I have Kenneth going first because he's definitely speaking. Then is your friend speaking now? What, Augustine?
Yes, but he kind of is strange. So he basically declared that he wants, and he wants to invite the people from his university to talk about their stuff because obviously they have a high-level synthesis group. And then he told, no, I'm busy, and so far I didn't see his friends. He just goes to state to work in some FPGA group.
Oh, there you go.
Ah, there you go.
So I'm not sure what happens with him.
That's it.
Oh, that's it now, that's it.
If these people we are getting early on.
That's enough.
That's enough.
Okay, so then you have Kenneth, hopefully.
Yeah.
Hi, sir.
Do we already know?
Yeah, we are.
And so say you will go with Kenneth from FPG for his very high activity first.
Sure.
Then if yeah,
Having USB, yeah? That's what you do?
Yeah.
There you go.
well, the first one is
They stopped producing it.
Seriously, Kenneth's one is like.
Interesting.
yes. It's going to be a very chop right? Yes. So I just got the key. Yes. That is exactly what I'm doing. So,
Counter on it.
Hi guys!
Live stream URL on the site. Live stream.
Let's wait until everybody comes.
Sure.
And I will open the links.
So you'll be demonstrating the icon setup.
Yeah.
That's the Altera, right? That's the Altera?
Yep. I'm not sure that I have a correct pinout though.
Oh, that's why I started
Got more functionality.
Yeah, that's actually quite a nice board for 60.
This one is too limited. The one is too limited.
Yeah, that's why actually I ordered the something that you can put into the same. It has the same pinout as a board, but under it has possibly a power. But I think for tutorials, this is
Yeah, this is where basic.
perfect.
But for basic like HDMI whatever, you cannot do anything. So
Yeah,
it's not
that's exactly because you need at least Spartan 6 and Cyclone 4.
yeah.
That's nice because and then you actually have other features like programmable clocks that you can change online. Actually, in this regard, I think the Altera is better because already Cyclone 4 has something that you can change the clock in the device dynamically. And in Xilinx, you need a Series 7, I think, to be able to, upclock yourself and downclock it. So if you really are serious into either power management or VGA generation, being where you have like 20 clocks for different resolution, that's
You can always generate like different clocks have a very high one and down count. I mean, down, sub count the clock. There's no need for really high.
not perfect, right? It's better if it's similar.
Yeah.
Because not all devices will accept it. And the problem is also the clock of VGA is very close to the maximum clock for Spartan 3.
Yes,
So it's
this
very,
one,
very hard to generate, down sample the clock. You would have a gas.
But there's some example when they go to 800 by 600, that's fine enough. Or it depends on what you want to do with it.
800 megahertz.
800 by 600 pixels. So the VGA mode.
800 by 600. But I wanted to have, for example, full HD.
Oh yeah, but then,
For this, you need at least 46. I think you could do with this. You can easily go to 1000 by 700. I think I tried 600. by 40, and then 800, and then I wrote a program that actually tells you whether you have sufficient clock. So I have this small Haskell program that basically find image VGA. This is my ongoing project. Modeline, I think. So I downloaded Modeline database from like from Xorg.
in August.
Yeah, but then everybody needs to come with their own board because I think Brahim has like 3 boards or 2 boards. I have 1.
Yeah, I can bring another one. I can use the Zoom. But in the meantime, if I don't use those ones, I can bring them and then when we announce, we can say there will be some board available.
Yeah.
Maybe 2 people can work on the same one.
Yeah.
If you could just say what we should look for in an AliExpress listing to get a board, that would help. I mean,
Yeah. Okay, then we'll.
All right, let's start.
Okay,
Hi everyone, welcome to Hackware.
Just try 1 or 2.
So how many of you are here for the first time? Great. So ignoring the bunch of people here. Who's here for the first time? You are here. Okay, not you. So we are a group of electronics, hardware, computer networking, FPGA, radio, I don't know, DSP, digital signal processing, everything bunched together. Not whatever is not software, we do it here. And slowly we hope to spin off little groups as the interest grows. We have meetups every month. So if you go to Facebook groups Hackware, maybe Michal, you can go to, is that your computer?
Yeah.
Yeah, you can go to Facebook Hackware group. How many of you are in the Facebook group? I think I see. If you are not, then you can join the Facebook group. If not, there is also meetup.com Hackware. If you don't prefer Facebook, you can come to meetup.com. And that's where we organize all the events, and you can ask questions and so on and so forth. So I think among the organizers, you can approach either me, Fazli is here, Chinmay, and of course you can also buzz people like Brahim or Michal, who are the regulars, if you have any question about Hackware in general. So we will start with Michal. He will be doing FPGA, Field Gate Programmable Array 101. Field Programmable Gate Array 101. I tweeted this once, and I think one of the software people were like, field programmable gate objects. No, it's a hardware term, and that's what Michal is gonna explain to us, right, Michal?
Yeah.
All right, and after 20 minutes, we will have 5 minutes Q&A with you. So, yeah, take it away, Michal.
I wouldn't stress.
Keep it.
Stop.
Okay, so let me explain the rationale for 20 minutes. Firstly, human adult concentration time is about 18 minutes, so 20 minutes is good. Next, we want to get on to Q&A, 5 minutes. But most importantly, we want to end it early so that all of us who are here can talk to one another. That's one of the biggest point of this meetup. It's not just we go home at 10 o'clock and then we're all sleepy. Okay, so that's the whole point of 20 minutes, so I hope you give enough motivation for that. So, yeah, let's get started.
So I will start with introduction. So the goal of this demo is to show how easy it is. But if you have a hardware, then we can make a workshop in Hackerspace that will take more time. We can answer questions. We can make sure that your small projects work. And for these small projects, the first question is what kind of hardware you want to have. Probably you want something like this. This is so-called Papilio. We can see on the web page, it is pretty easy to buy. It's actually popular. You can buy something like this from, yeah, I always make this mistake. It's just one L, yes. On this webpage, Gadget Factory, it's basically a simple Spartan board with shields. I would recommend either Oberon Project Shield, which basically has the VGA output and 2 PS ports, so you can connect your peripherals. It also has the mass storage, so you can do most of the small projects. Yeah. Or Logic Start Shield. This is the example of Logic Start Shield. You have switches, you have LEDs, you have 7-segment display, you also have VGA, and you have audio output. which is pretty practical. Also, you have alternative way of connecting power. There is also the third shield that you may want to have. This is the so-called gaming shield that has VGA and two slots that look just like VGA. They are actually joystick slots. And that would be the best ones. I would probably start with overall shield, but as I will tell you in a minute, as long as you have the right socket, you can do everything. If not, you just need an extra connector that converts the pins to your socket. Yeah? And that would be as for hardware. So I would recommend either Spartan 6, so Papilio Pro, probably. This is Papilio, just small Papilio. Papilio 1. Very practical for small projects, but it doesn't have its own memory. So it has memory, but it has like 40 kilobytes. And the Papilio Pro has 1 megabyte. So if you think about visual projects or gaming projects, this is enough to have a mono display, for example. But if you want to have like color VGA resolution or HD resolution, that would be already about 1 meg would be taken just for the display memory. That is important. Also, the common thing with FPGA is that you have like 2 or 3 bits for each color here. So you can count that you need this, at least frame buffer memory. That's really bare minimum unless you use character generator. But then the character memory will take some, and it's of course monochrome. So now the hardware considerations are after us. The next step is, of course, visiting, depending whether you have Xilinx or Altera FPGA. These are two most popular producers. Yeah. So depending on which one, you need to visit either Altera.com webpage or Xilinx.com webpage and download the software. I have the software already installed. You basically need to download so-called ISE Webpack for Xilinx and starter edition of the software for Altera. These are kind of free editions, so they are limited to working only on the producer's devices, and they are licensed for all the producer's devices. So that should not be a problem. So this is the bare minimum. For the low-end FPGA is completely sufficient. And now I will show what happens when you download it already. So this is Quartus. So maybe I will start from, I will switch off the pin planner because that's a bit ahead of what we are going to do. Yeah.
And it works on Linux.
Yes, the thing is, there is a Linux version of all this software for these major producers and Windows versions.
Okay.
Even for Diamond or Lattice, there is a Linux version, but the problem with Lattice is that you have special Red Hat version for it to work, and it's pretty old. So I would recommend either Xilinx or Altera. Software works on, as far as I know, like most platforms, two most popular platforms, maybe not on Mac. That's the only difficulty. But you can have the Parallels desktop with Linux. It will also work because the only way it contacts the hardware is USB. Yeah? And then when you start Altera, Quartus, you see the display like this. The first step that you need to do is to create a new project. I'm not sure, is it enough resolution? Everybody sees it? Okay, so I didn't need to zoom it. So you create new Quartus project. And then we call this a tutorial project. And there are two important things. This name is usually the same as this name, and this name you need to remember because it has to be also the name of the top level entity in the project. I will tell about it in a moment. And we don't use existing project settings because I want to guide you through few things that are usually difficult, because then everything else is simple. So you create a directory. It's very similar to Xilinx, but I will also do it with Xilinx in a minute. So, something happened. It's kind of slower than usual. Maybe I should just close the software. So in case it is slow, the beginning projects are very small, so we can just kill the software and nothing bad happens. So it's really robust. So usually it installs in opt-altera or opt-xilinx, and you just need to call it from this directory. Yeah. And it started. Oh, this is the Xilinx version. So, okay, we have a new project. Okay, we can also start it with this wizard. So, new project. As I said, this is the important part. Now we create the directory. No. Now we create an empty project. And we don't add the files, we will add them later. Now is the most important part. So the first thing you need to check is on the chip you have the code. And this, as opposed to other chips, all the numbers here are important. So I will show the two examples of chips. So maybe in the camera, is it visible, the marking? And here. So these and this here, they have a special code that we will use in a minute. So whenever you have development boards, sometimes if it's, say, Altera's or Xilinx development board, you will have a tutorial that tells you what to choose. But here you just need to copy this number. In my case, I know that it's EP for now for CE 6, and now it will be E22C8. That's the beginning. That's actually one of the most difficult things. Why? Because now you select the voltage, now you select the number of IOs and pins, now you set the arrangement of the banks, and if you select the wrong device and you compile your project, it will upload, it will connect random things to other things, or it will not upload at all. So that's the critical part. So now I select this device. I have some problem with this actually. No, it works here. Yes. And now is the things that is best to keep at the normal settings. It just allows you to change the compiler and so on. So I would not recommend to change it. Here it should now display the Cyclone 4E, the kind of device. Also other things that are probably not that important. So now the compiler knows which device we target. And the next thing is to add the source file for VHDL. Oops. And it's also pretty simple. You just add the VHDL source file. Say, I have one prepared actually. It's a very simple file here in LED link. So how this file looks like. It's basically VHDL code. If you Google for VHDL tutorial, it will tell you everything about the language. It has normal imports. Usually you import the IE stuff because it's the standard types and declarations. Second, it's declaration of the inputs and outputs of your entity or your module. In this case, it's logic vector 1 of 8 bits, both switches that are inputs and less that are outputs. So this corresponds to what you see on this board. Here we have 4 switches, but I can always connect the pin to something that doesn't exist, and hopefully nothing will happen. I mean, as long as the voltage doesn't exceed the nominal voltage that is accepted. And here we will say that depending on the state of the switch, we will set first 4 LEDs and the second 4 LEDs we will set to 0. So we don't care about 4 LEDs that much. So this is very easy to program, and whenever you program it and you add this file to the project, so we add it to the project. We have to click add. Okay, we have added the file. The only problem is that we need to rename the entity here to new project so that it's consistent with our project name. Okay, that would be all. Now we are able to compile our project, or should be able to compile it. So now we can start compilation. And the next most important thing is twofold. So either we try to implement it directly in hardware, and this is also the same in Xilinx and Altera. We have to, there is some, so I probably have another file that also specifies new project. So I need to copy let blink VHD to the project directory and just keep it there. And besides that, yeah, that should be okay. So that was VGA tutorial for new project. Yes, it probably generated another file that was responsible for this. So when we make this compile, basically, because I have only 5 minutes, so I need to skip this part of checking, we need to assign the pins. So in Altera it's pretty simple because there is a graphical pin planner that has the pin numbers that correspond to the pins here. And we just assign the pins to the names that are used in the VHDL top level project. In Xilinx it's a bit different because we have so-called QCF file. I mean the constraints file, yeah. So if we look, I have another project here, and that's actually put in here. There is also the CSV version, but I didn't use it here. It generated the whole documentation here. QCF. UCF, sorry. And that's the file that you should actually usually get as a template from your board manufacturer, so that you know what is connected where, basically. In this case, I got it here in this way. And it defines basically which pin name corresponds to which name. So on the left you have the clock, RX, receiving, TX, transmitting, serial, seg7 is 7 segment, display anode, dot point, and so on. Then lock is the pin name. And then also there is an option of IO standard or period for the clock. So basically options of how to treat this pin. Sometimes, so usually FPGA have few sets of pins that are so-called IO banks. And each IO bank can be used for either low voltage TTL, sometimes also high voltage TTL, so normal TTL. And you can also modify the behavior of the slew. So how is the edge detected? So that the voltage races. And the drive, in this case, selects how strong it is, the pin is driven when it's output. Of course, you can also select the pin to be in-out, and then depending of whether you mark it in or out, you will be able to drive it as output and as input. Of course, in this case, beware, do not set it as input and output at the same time. Yeah. Then the second thing is simulation. So basically for each of your projects, besides pin planner, where you assign the names of pins, you are able to run the simulation tools after compilation. Here it's RTL simulation. In case of Xilinx, and I think in this case I will show the simulation in Xilinx tool. So this is actually a project where I added few files already. I created empty project, added few files, and selected the target Xilinx device, also from these numbers, the same way. And then I can run the simulation. In Xilinx tool, the simulations are here as processes. So basically, you can click what you want it to generate here. Here it would be generating programming file for the device, and simulation tool is here. And then it should run the other program that is just simulating. Okay. Yes, because now we need to simulate, explicitly switch the mode in Xilinx. In Altera, you just launch the simulation tool. Here we have either a selection of implementation mode or simulation mode. Okay, I'm finishing. And here, when you select certain time, in my case, this is an example VGA controller, like 100 microseconds, and you run it for this 100 microseconds, you will see how the states of the outputs change. You can also have a separate program that tells which inputs are set in what way. So you can simulate what is on the pins that are outputs depending on what you set on the pins that are input. And that's basically the whole philosophy, besides knowing the language of VHDL or Verilog or Clash, whatever you prefer as an implementation language. Yeah? So we simulate because some kinds of the programs basically work too fast. In case of VGA, the step here is like the whole frame is generated for approximately, I think, 10 milliseconds. And that's the whole display. So each pixel is generated for a few or tens of microseconds. So it's very hard to debug without simulation tool. Yeah? That's also true for the most protocols. If you write something to flash memory or read something from RAM, you need to do it pretty fast. So you check it in simulation tool that the pins, the digital data is set appropriately. Or you directly go to the device and then you can see the LEDs, but maybe it's hard to see if they would change very quickly. So the first mistake that people usually do is setting the clock inappropriately. But if you have your manufacturer's constraint file, that should settle the issue. And that's the only thing that I will not have time to demonstrate, but if somebody comes for a workshop session, I will show you basically how you set the clock, both in Quartus, and in Altera's tool, and in Xilinx tool. So you basically need to know your crystal frequency on board. In this case, I think it's 25 megahertz. In this case, this is 32 megahertz. You set it in the tool, and then whenever you want to wait for 1 second, you also set the constant in your VHDL file to be 32 megahertz, so 32 millions, basically. Or if you have more accurate the crystal, then it will be appropriate power of 2, that is closest to 32 megahertz. That would be all. Now time for questions.
We have a couple of questions for Mina.
I think we should say about the price of those boards. Because
Yeah.
it will really indicate, it's not. It's important.
So,
Yeah. So
this
this one was, I think, $70.
Yeah.
The machine was Singapore dollar. Actually, the red one, I bought it from 12 gig for $70. So yours, I don't know.
This with shipment from China, I got a stock of Chinese marked boards that are initially a little bit hard to work off because it's hard to obtain the pinout. This is only a non-standard thing with such a board. But if you obtain the PDF with a pinout, and if you decipher the Chinese, it's actually a very cheap board. It was $66 with shipment. And this board actually has not only the cyclone itself, which is a bit more powerful than this one, because, for example, it has programmable clocks that you can change, and a bit more of connectors, which I said for the hobbyist and for the initial experimentation, it's very useful to have PS2, to have VGA. So I suppose without shipment, the price would be $46. That's what I paid.
Okay, we'll go for one more question, but where is Andreas? Maybe you can start setting up.
So I can answer a question, and
Yeah,
I
then
can
you can
help
set up.
also.
While, Brahim or Mina, could you talk a little bit about the FPGA group that we are also trying to start up?
Okay, so we created a group on Facebook, FPGA Singapore, I think we name it at least. So we will try to meet once a month, it's the same basically session once a month, and create some workshop / tutorial / introduction. So basically introducing how to program FPGA. If people are interested to build something on the top of those boards with specific interface, learning how to program to drive an LCD, to do some analog measurement, sound synthesis, and because those boards have also VGA and HDMI, is to create some graphics, etc., etc. So the first few sessions will be probably just to introduce VHDL or Verilog, and the first session don't know exactly the format, but people can come with a laptop, install the tool, and just simulate, because we don't need really the hardware to do much. We can also import an image into the tools using the VHDL code, simulate what it would be the results. Then the image is basically created, because we can input and export also the data. So there could be some session where it's only a programming exercise without any hardware. Then later we can have more evolved tutorial depending on the interest of people. And
I mean, if you have done VHDL and FPGA in school, so maybe some of us who have already done before a long time ago, we can join and then kind of bring in and create the community.
Anything you want to know?
Yes.
I want to point out, I see Webpack when I installed it, I didn't install the FPGA tools because I only use CPLDs, and the installation size is 15 gig.
yes,
So I just want to point that out.
Yeah,
You start on the house.
So for Altera tools, it's under 5 gig.
Yeah.
That's certain advantage on the part of Altera, but on the other hand, the Xenix tools are just better. So this is because you really install this simulator that shows you really nice waveforms. It also has the choice of CPU compilation mode, so there is more for optimizations. Unfortunately, they are not all activated by default because you sometimes need a license. That's no problem, unfortunately. So I would recommend people to download it in advance, and for the workshop, I think I would just download the latest version for both Windows
When is the workshop?
and keep it on stick. So we will have the meeting for those people that are interested at the end of August.
Okay.
If you can bring basically your toys and show something on these toys.
22nd.
Saturday, 22nd of August.
Saturday,
Yes.
22nd August. So just keep a lookout in both meetup.com as well as Facebook, whichever you are comfortable with.
Yeah, and tutorial, as soon as we have people interested, I think we can do it either in September probably. It's
Yeah.
best time.
We will probably have a FPGA 1 or 2 at Hackware as well, so that Michal or Brahim can share. Right, thank you so much, Michal and Brahim.
Thanks.
So for those of you who have arrived late, not to worry, big thanks to Mike Cheng right here. He's a big programmer and co-father. He is also recording these as part of Engineers.SG. So if you just hit Engineers.SG from a web browser, you will come across a YouTube playlist, and you will hear Michal's talk there as well as others. So next speaker we have is Andreas, who I don't really know what he's going to talk to us about, but I know he has a lot of pictures to show, and pictures are always interesting. Okay, Andreas.
Okay. All right. Well, it's my first. Oh, yeah, the clock is running. So it's my first time here at Hackware, and after hearing Michal talk about something that I understand a little bit, I hope I'm right here with what I have prepared. So my background is in the arts and design, but I've been working with software and hardware for quite a long time, and I use it in my practice. So I write software. I've been doing this for a couple of years. I make hardware, not very high tech like this, but very low tech. You will see that in a bit. And I think I will talk a little bit about the in between the arts and technology. I teach at LaSalle. I also run a small lab at LaSalle, the Media Lab. And it's mostly about using technology within an art practice. It's about collaboration, and it's about making art with technology. Just a few examples. That's how our teaching space looks like. I think what is very important for me, or what I have figured out over the years, is that you have to work together as a team. You have to gather around the table, and you have to put all the stuff on the table and just figure out what all these things, especially electronics, are. We work a lot with Arduino boards, so I think again after seeing these boards here, I think for you guys that's like children's toys, but I think we have been quite successful in getting students interested in technology using these boards. In terms of materials, yeah, we use a lot of electronics, but very big electronics, not very small electronics. So listening to Mihail earlier, I thought, you know, you guys probably use tweezers, and I would use a hammer instead, you know. So I think we work in larger dimensions, I guess. Prototyping and developing everything from scratch for me is very important, and I also try to pass it on to my students to build with what is available, to build with very cheap materials. That can be wood, that can be cardboard, that can be what is just available, maybe an art friend. And I try to convince them that you can make great things with it. So this is my Arduino collection. There's more, but I'm very proud of the Arduino, the big thing there in the background. One of my students brought it back from India when he was visiting home, and it's like really double the size of a normal Arduino and comes with big parts. And of course, we work with Raspberry Pis and other systems on the chip. ESP8266 I'm very excited about. So I think these are not really foreign islands for us, so we're trying to get on the train of this constant development of technology. I think I have to say, I came here in 2008, and when I asked our finance department to buy some Arduino boards, they were like, what do you want to do? Arduino, and they couldn't even pronounce the name. And I think after these 7 years that I've been here now, or almost 8 years, that definitely has changed. So people know now what is an Arduino board, and I think this is also due to the community. So I think that's really a big component in Singapore that promotes technology, which, as I said, 8-7 years ago really didn't exist. Even though I speak of the arts, but yeah, now with 12 Geeks and all these online shops for students, that's really great to get into electronics and have access to it. Just two projects that I like. 2008, Ong Kyang Peng made this device which he calls a flat helmet, and it's the visor, which is hollow inside. And on his backpack, back then there were no mobile phones, so he had to use, well, I think today you can really compress it into maybe a quarter of the size. So he was carrying this backpack with his laptop, with a water pump, and he mapped his location, his physical location, against the map that he got from the NUS water department, which predicted the water rise in Singapore in the next 50 years or in 50 years. So he would walk around with his visor, and whenever he got to a location where the predicted water level would rise, so the blue water in his visor would rise. So it's kind of a this real-time, on-the-side visualization of something quite scary, which might or could happen in the next 50 years. Another project is by Mitru Vigneshwara, who built this little device that kind of looks like a camera, but is an object that you can point in any direction, and it returns the emotional states of cities that are within the, what is it called? Within the radar, field of view of the camera. It's a little device, custom built, laser cut, Arduino board inside, compass inside. At the back you could slot in your mobile phone and then connect through Bluetooth to the Arduino board, and then the compass would tell you which direction are you looking at, and then the data would be displayed on the display. The data was collected from Twitter over 30 days, and then evaluated based on keywords like happy, sad, aggressive, and so on. There were eight different categories, and just some of the data collected you see here. And interestingly, where you cannot see it, but South America turned out to be very aggressive. Hong Kong and Singapore turned out to be quite boring. So there's 7 lines, so each line represents 1 day per week. And Hong Kong is, not even the weekends get exciting. Yeah? So every day is kind of the same. Singapore kind of looks the same. Buenos Aires on the other side is very aggressive. Yeah? A lot of purple. Jerusalem was the only city which was very anticipating. Probably has a bright future ahead. So, I mean, these projects, if you look at it from a scientific perspective, I think they might not have, like I said earlier, they might not have these values or data that you pick up with a tweezer. So it's more like, with a chisel and a hammer. So the data is quite raw, but I think the idea, or just coming up with this idea and making it happen and making it show to the world, or showing it to the world, I think that's what I appreciate, and that's also what I try to convince my students to do. Teaching, I have one class that is called electro sounds. So I teach that to music technology students, and when they come to me, they don't have any technical software, hardware background. They play an instrument, they're interested in electronic music, they're interested in their effects, and they're quite good at that. But when they come to me, so they have heard of an Arduino board, but they haven't touched one, or they haven't programmed one, or they haven't worked with one. So what I do with them then is we build our own instruments. And I think it's very important to not educate in a very generic way. To say, here you have an Arduino board, here you have the Blink example, here you have other examples, and then just go through the books. I figured it's very important to relate it to the practice, to one's practice. So I teach fine arts, I teach design, I teach music technology. And for each of these different disciplines, I have to adjust my teaching methods, and I have to adjust to their practice and to their interest. Otherwise, I fail. So I think it's very important that students really can relate to what they make, that they can relate to what they use in order to make this very dry and very scary subject interesting. Surprisingly, most of the students come to the arts because they didn't like the science. So they come to my class, and then they, have to write software or make hardware.
That's why we use these LED shields.
Just one example. That's an electro zither, so adapted from the instrument zither. That's Zig, and that's his instrument. It's a lot of noise. I think this is how you experience the technology that you build. That's how you figure out, okay, if I do that, this happens. If I do that, that happens. These are early experiments, so after a while that gets much more fine-tuned and much more sophisticated. But students are also exposed to making their own instruments using physical materials. Today students come with a laptop, and a lot of students think everything happens in the laptop. So when I tell them, hey, but we get a little bit physical, we have to really use our hands to make, in this case, an instrument, then some of them haven't even touched some wood tools before. I think, which is not bad, but if you expose them to the workshop that we have at LaSalle, they get quite happy, and they're quite happy that they build something with their own hands and laser cut something with their own not with their own hands, not with their own lasers, but they initiated that process. Very important, I feel, is to have a public presentation where you present the tools or the instruments, in this case, that you have built. In that case, that's the Art Science Museum. They have this monthly events, which I don't know, has anyone been there, where they invite schools, NUS, NTU, Polytechs, to present student works, and I think for students that's a great exercise and great exposure in order to show their works. And also to get feedback. I have 8 minutes left, so I just flipped through these images because I want to show something else. Very important for me is light and wood as a material. So I think looking back at my work over the past 5 years, I really have used these materials excessively. So wood for me is really easy to work with. I can cut it, it's very solid. I can build large, big sculptures, installations. I can unscrew them, I can pack them, I can do a lot of stuff with it. And lights coming from a screen-based background, I think lights is still the closest to where I came from. It illuminates a space, it creates emotions, and that's why I really like to use LED lights. I just show a few videos that hopefully don't need any more explanation. So from a small model, then to a prototype, and then to the sculpture. So it's part of one larger work. That's the circuit. So it's A3. Strangely, we defaulted back to breadboards. I think we find it really easier to replace parts or to quickly modify the circuit. We tried prototyping boards, soldering, night sessions of soldering. It just didn't turn out so well. So we defaulted back to breadboards, and I think breadboards actually is a quite great. It's a great material for the things, at least that I do. And then, from the small prototyping box or model, it kind of got applied in many different applications over the past 3 years. Installations, site-specific installations, theater performances as a stage design, sound performances at the Art Science Museum, again LaSalle. And now we are preparing another collaboration together with the dance department for the Night Fest. And these are the initial tests for this new setup. I want to talk, the last 5 minutes I want to spend talking about a project called Urban Explorations, which started in 2012. And I just came back in June from Paris, where we did the second edition of the Urban Explorations project. The Urban Explorations project is a project that looks at an urban environment. We build our own tools to sense that urban environment, to sample that urban environment, bring back the data, kind of try to make sense of it, and create an artifact from it that we then exhibit. In Paris, we spent 5 weeks conceptualizing, building, evaluating, and exhibiting our works. These are 2 works that have been built. One, Ong Kyang Peng on the left. Is it the left? On the left, he built a 12-channel sound recorder that he would just put up in different locations in the city and collect sound intensities that would come from different directions. And then he would build small sound sculptures from it. On the right, that's my colleague Patrick Kochlik from Berlin. He built a frequency sensor. It's basically a DVB-T
Yes.
Antenna that allows you to scan the frequency spectrum. It starts at, I think, 800 megahertz and then it goes up all the way to 1800 megahertz, 1.8 gigahertz. So he would just go around in the city, set up his little antenna, and then collect data for 30 minutes. And these are all 9 tools or instruments, data collection instruments that we have we built. Top left, Wei Sim, she just went around sampling whatever is on the floor and putting it into her bags and her suitcase. Then the second one, that's on Campaign, 12-channel sound recording device. On the right, that's a pigeon camera. So it's a platform with a few buttons, and whenever a pigeon would come and press one of those buttons or initiate these buttons, a photo would be taken of these pigeons. Second row on the left, that's my project I will talk about in a second. Patrick's in the center. On the right, that's Cindy's snail lab. She would go around in Paris and look for snails, look at their pH values, bring them back into the studio. Big mess. No, it was great. Yeah, work with snails she would find in Paris. Bottom left, that's an extension for a mobile phone. It's a magnifying glass or a microscopic with a microscopic lens. The next one, it's a stethoscope for listening to buildings. So there's a piezo sensor, and you just put it on top of buildings, put on your stethoscope, and then wait until it starts moving. And some of them actually did move, or data was recorded. And then the last one, the shoes. The heel, you can take off the heel, and then it's hollow, so you can put in some sensors. And the whole idea was to put in some sensors and collect data while you were walking. These are the 9 projects that we created over a period of 3 weeks. And I will just talk a little bit about my project, Movement of Things. And it's about this little chip here, which I'm quite excited about. I think you guys, I have 1 minute left. I will. This little chip was designed by a French startup called Tangible Display. Maybe some of you have seen this guy, Cedric.
Yeah. He's spoke at Hackware.
Sorry?
He spoke at one of the older.
All right.
Hackware,
So I met him here in Singapore, and I was quite excited about this little chip. So it just runs off a cell battery. No wires involved. There's an accelerometer, magnetometer. It gives you 6 values: acceleration XYZ and orientation XYZ. And I thought that was great for what I wanted to do, to record the movement of things. I could just use this little chip, attach it to different objects. In this case, it's a piece of plastic, a roll, quite heavy. And you will see that later in the video. I would just roll that piece of plastic along different surfaces and then record the data that these surfaces would resonate to. It advertises Bluetooth LE, so it just sends out data. The data is included in the description of the chip, so you don't need a connection, so you just turn this thing on. You have, in this case, an Android application running that just listens for these advertising messages, and then you just snap the data and record it or display it, like in this case. So that's how I would run around in the city. This guy attached to 6 different microcontroller extensions, I would call them, for different purposes, and then have my mobile phone record the data. think that was my favorite. So this air vent with all the metro air coming out, and that was very strong. The tool that I built here is just a plastic bag from a shop, nylon strings and what's that called? A backhoe. And that's the data that I got back, displayed as a graph. Time, 6 lines, XYZ acceleration. I have a close-up. XYZ acceleration and then orientation at the bottom. That's from a water canal. But of course, that's not very pretty to me. That's too raw. So then I tried to find method. Oh, I'm running out of time. I ran out of time. I just go through some images that show how I kind of beautify the data or make them pretty or beautiful myself. How I translate this whole experience into small little exhibition objects. Again, the plastic bag, then the helicopter we found on the streets, and then a ping sensor just to activate the helicopter. That piece is called X versus Y. So I took the Y channel and the X channel of a data set and then played them back using a stepper motor, and I had these feelers, and there are nice moments when they kind of wiggle or when they touch each other or when they move fast and are very hectic or very calm. So these are kind of translations of the data into something that might be a little bit too abstract, but kind of resonates my experience or the experience of that process. So that's the exhibition. These are some shots from the exhibition, and I'm done.
Awesome, thank you. So he mentioned Night Festival. I remember some of your students last year had some projects there. So this year they're having as well.
Which project was that? No, I think that was LaSalle. They're everywhere.
Yeah, they're like everywhere.
No, but the iLight Festival, but that's already like
yes,
3 or 4 years ago. We had a piece there. So Night Festival, we're gonna be at the deck. I don't know if you guys know that. It's photography space, exhibition space, right across from LaSalle. So it's containers, stacked containers, and they converted that into an exhibition space. So we're gonna have 2 containers there, and we're gonna have a performance using boxes, wooden boxes, light strips, LED light strips, and the Twiz.
Cool. Questions for Andres?
Yes,
So
please.
how do you get your ass into programming? Where do you even start?
Well, first of all, they have to take the class. First I started using processing software, screen-based outcomes. But I feel that working with an Arduino board, I mean the language is the same, almost the same, makes it easier to pick up these principles of these languages or object-oriented programming. So usually we start with an Arduino board. We go through some of these examples just to get the basics down, and then they either build instruments, like in the electrosounds class. I have another class called drawing machines, so they build drawing machines in fine arts. When I work with dancers, all the work is on my plate, so it's more about feedback. So what does the dancer, what does she want to do, and how can we work something out so that she can do it. But yeah, so usually I start with Arduino, and I also teach a class then in processing. So that's usually the path of getting them into coding.
The accelerometer, the small chip, what's the name? What is it?
It's called the Twiz, T-W-I-Z, Twiz.io. It's by Tangible Display. So it's a small startup from Paris. and they have a very funny studio in the suburbs of Paris. I think it's not in production. No, it's not in production. So thankfully, I got a couple of them to work with and experiment with. But I think they're also very excited to see, okay, what can you do as an artist that looks maybe a little bit different than from what maybe a demo, an engineering demo would look like. So I think we had very good discussions and good exchange. And yeah, so let's see what this dance project, what will come out of this dance project using the tools.
All right. If not, thank you, Andres. We hope to see some of your students come and present as well. We would love to. Because I think as electronics, when it gets merged with arts or science or any other things,
Yeah.
hobby projects, sometimes.
I mean, later maybe if we have a little bit of time to
Sure.
talk on an individual basis, I think I would also be interested what your perspective is on how artists or designers could come into your domain. And yeah, maybe I just leave that here.
Absolutely.
So,
Thank you so much. Thank you, Andres. So if any of you are also teachers or professors in the academic world and have interns or students, we welcome your students to come and present as well. Alright, so we will go for the last talk. Is Kenneth here? Kenneth, alright. So is Augustine here? Alright, so Kenneth will talk about Cupcake. It's going to be a lightning talk, 5 minutes. So once again, the Twiz, Cedric, engineer behind, one of the engineers behind Twiz, did come for Hackware. When he was in Singapore, he was very involved in Hackware. We were so lucky to always have visiting geeks coming and sharing with us. I'm sure if he's also ever in Singapore, you'll definitely come and meet.
he's very active. So
He's very active. He's very, yeah, exactly.
he's a great guy. Sorry?
Right now he's in France. Now he's in France, right? I'm in France. Just kidding. I'll tweet him. People are talking about you. He'll miss us and he'll come back to Singapore. Okay, so that's Augustine. By the way, all the links and everything, whatever we discussed, I think me, Fuzzy, or whoever will post it at Facebook, Twiz, Cedric's link, Lassell. And
Websites.
sorry?
Share the websites.
Yeah, I guess for those of us who don't like Facebook and right, open, right? Is that right?
Yes.
Email.
Do you need Wi-Fi or?
Yeah, I'm connecting now.
Do you know the?
Yeah, it's there. Yeah.
I know, right? Yeah. So how many of you are once again here for the first time? I know some of you came after the. All right, awesome. So this is like an open, free electronics, computer networking, amateur radio, you name it. Whatever is not a programming language, this is the group of it. And of course, it's not only a programming. Of course, it is HTML or very long or assembly. Yes, of course, this is where it happens as well. If it's not a high-level programming language, this is where it happens. And of course, like Michal and Brahim was talking about the first talk, FPGA, field programmable gate arrays, and maybe amateur radio. Slowly we'll try to form specialized groups. All right, Augustine, you ready?
Oh, Kenneth.
Oh, sorry, Kenneth, I'm so sorry.
Yeah, no worries, no worries.
All right, Kenneth, you're ready.
Okay, hi everyone. So this is actually my first Hackware attendance. Thanks so much, Brahim, for inviting me. Chime for inviting me. And yeah, I come in with a background of no background. Meaning to say, before I started like on these, a few, I had no experience, fixing my stuff for me. Is the guy who fixes stuff
also, and only recently when I started working for the One Maker Group in February, somewhere middle of this year, that I really started to get involved in all this kind of stuff. And my first project that I did was inspired by this video on the cupcake. I don't know whether you guys have seen this video on the cupcake. For those who haven't, maybe I'll just play it to entertain all of us.
Adafruit presents Cupcake! Featuring the world famous Raspberry Pi computer and Adafruit Pi TFT display. They've joined forces to play classic 1980s arcade games. Take it to the pizza parlor. Take it to the park. It's so incredibly cute you might just throw up.
I still suck at these games.
Okay, so this is actually the a thing I found maybe on one of those like Facebook, like, you know, when you see interesting things on Facebook, you can click, and I was blown away at like how you can actually build something like this. So I did an impulse purchase. I bought a kit online from Adafruit, and I actually procrastinated on it. I bought it last year, and I only really started getting back to doing it when I joined the One Maker Group, because you know you have all the stuff there. So I'm really glad to say that, like, for a complete beginner, assembling the kit only takes like 5 hours, and you can actually get it to work. So this is it. Yeah, it works as advertised. So there is no tricks involved, and I don't know how I can let you all see the thing.
So maybe you can just give a quick demo now, and then we can all sort of crowd around.
Yeah. There's a few stuff I want to demo for you all. So find the table. Yeah. So the thing about this is that there was no programming involved. A lot of people who ask me for, you know, I learned coding in a few days. I learned how to code a game into the Raspberry Pi in a few days. No, all you have to do is flash an image that Adafruit already makes for you, and you know the games are just transferred onto it by dragging and dropping onto the folder in the SD card. So it was really idiot-proof and beginner-friendly. So yeah, it's very rewarding, because when you have this kind of outcome in your mind, it seems more rewarding to do something like this, because you relate with what you're building, right? A lot of the courses I see on electronics had boards with like flashing LEDs and what, and I couldn't really relate to those. Like, I don't see all these components in my day-to-day life. They look like the really high-end stuff. But when you put it in this kind of package, to Adafruit's credit, you can really you know, be inspired to work towards something that you feel you understand, and other people can understand. Because even if you don't understand a board, I think everyone will understand Pac-Man. So yeah, so in honor, you can actually play a lot of games on this, but I chose Pac-Man to make it like as relatable. I feel that it's testament to how great this product is, because after I built it, like, I work in Simplified, and my boss's kids come into the office and they spend time playing with this on their own. So okay, so it's on. I don't know whether you can see, but I think you can hear it.
We play with it.
Yeah. So it's actually running. Okay, so I'll plug it up. It's very noisy. Okay. So this was the first step, and I was thinking to myself, if you can inspire someone like me with no background to build something like this. 42 seconds. Why not take it one step further and make a wooden version? You know, in the process, teach people things like laser cutting and soldering, and add this customization element to such a product. So my vision for this is actually, I'm trying to figure out, you know, can we hold a class for absolute beginners to make like a range all this, like clear acrylic, black acrylic, wood painted with like flowers and all that, on top of, you know, programming it with different games or functions, and have more interesting electronics classes for beginners to jump in with. That's really my goal, and I spent an entire month doing things the hardware by, if you look behind here, there's an interface board which I created from a proto board from scratch. It means I soldered all the connections instead of joining the pins on a breadboard. So with no background, the board alone took me a month. Creating this, the measurements for this case took another month. It was 16 times of laser cutting that I did at the One Makers Group. I think Leon, you have seen me struggle with the machine over there, which is something that I really appreciate the One Makers Group to allow me to do, because no one else has access to that much free laser cutting. So, yeah, it's a perks of the job. I get paid for it, you know. It's like in other cases, where can you get a giant laser cutter to prototype stuff like this? So, thankfully, it works exactly the same as this. And yeah, I feel that this 2-month-long struggle to get the wooden one work was worth it, because maybe I can get advice from you guys down here, the gurus, on like how can we make something like this accessible to more beginners to learn how to make. So yeah, that's it.
One question for Kenneth.
I haven't uploaded it. I literally just finished the measurements 4 days ago. So yeah, not yet, but I will definitely upload this to let people try it out. Yeah.
Were the original files from Adafruit? Did they put it up there?
Yeah,
like
the
measurements and stuff, or did you have to design yourself again?
So the image file is downloaded from Adafruit.
But the casing?
The casing measurements. Okay, people asked for it, but they only wanted to know the external visible like casing parts. So those were put online, but they were also put on a PDF file with the measurements. So I literally had to just strip the whole thing and measure with a vernier caliper every tab. Not fun, not fun. Yeah, and it took quite a while, let's put it that way. But
it came with the case or without case?
It came with the case. Yeah. So the kit originally comes with the case and everything except the Raspberry Pi. So one of the things I'm struggling with making a cost for this, right, is that this, right, costs 160 Singapore dollars to make, including shipping. So if you hold a cost for this, how much is it going to cost? You know, $200. Will someone pay $200 to make this? Like learn to make this? I don't know. And then, so that's why I'm trying to cost down it by making it with wood and like doing the board with like resistors and what. So yeah, like maybe you can make it cheaper, I don't know. No.
Awesome. So we will.
Sorry?
Copyright.
What do you mean? Copyright?
No, I guess he's asking if
It's
the
open
original
source
one has.
hardware.
No, the original one.
Yeah, why?
Original.
Does it have any copyrights? Is it copyrighted, like the design?
Probably open.
It's Creative
By cupcake.
Commons, yeah. So I mean, I honestly didn't check. So I don't know. Maybe I'm doing something illegal. I don't know. But I was just very motivated to see whether I can make a wooden version. Yeah.
Knowing Adafruit, or do you know who's like actually designed the story? Is it Adafruit or someone
Okay,
else?
the guy is called Philip Burgess.
So I'm
maybe I can ask
guessing
him.
You should, but I would think it's probably going to be
Yeah, it's
Creative
Adafruit,
Commons,
right?
or
So it's
yeah,
probably
they
open
are
source
very
hardware.
pro open source and
Yeah.
That's a relief. Yeah, this guy is incredible. He makes all this kind of stuff.
yeah. I mean, if you message him and send him your design, he'll probably like give you extra tips on how to.
Yeah, hopefully. Yeah, the goal of this is just to make a more interesting lesson. Actually, yeah.
What about building a bigger one with a, like
I get a lot of requests like that. I was thinking, can I start a company making big ones? Then someone actually in Maker Faire actually already does
Yeah,
that.
there was a company at Maker Faire that does
Yeah,
that.
I was a bit disheartened. I was like, oh, someone's doing it, but it's
If
fine.
it's that good, somebody has done it.
Someone has done it, but his one is different because his has you have to put your laptop inside or your PS4 inside, and then you play your game on that. So I have to be able to afford a PS4 and a laptop. So for my argument is that, I mean, I'm not trying to compete in terms of product. I'm just trying to compete in terms of what can we teach people to make. And I think making something tiny and cute and affordable like this is much better lah. Maybe if you can pay more. There are, okay, in the US there's this company called Nano Arcade where they make a lot of very funky decal, like these kind of things. But I'm not too worried about that because like I said, I'm here to try to teach people how to make this more than to sell this product.
Are there
Yeah.
some place in Singapore where they still have the real one?
Yeah.
Where?
And
Okay, behind Brian.
So, are there still enough GPL to maybe put in another set of joystick and maybe
another set of joystick? I don't think so.
So it's not just a single player kind of.
Okay, yeah, a good question. I have no clue. I'm really honestly, okay, so the drawback of making something like this, right, is that you can go through all the steps without having truly learned a single thing about electronics. Like, I still don't understand exactly how the Raspberry Pi works, to be honest. I only know how to upload an image file onto it, and that's it. So that's a drawback.
There's more than 3 gigabits.
Yeah. No, and it reminds me of another drawback. It runs on the Raspberry Pi Model B. So if I want to keep making more, I have to probably eventually configure to Pi 2, for instance. And I have no clue what's the implications of that.
Shouldn't
It should work.
Yeah, I guess. The image file is probably not. Yeah.
Yeah, you might have to change the interface board.
I might. Yeah.
Actually, that shouldn't matter. What should matter is the connector might be different. Because it's slightly, the connector has moved, some of the pins have moved. Isn't it?
No, it's extended, so it's 26 to 40.
48, the
Original two states. Yeah, even the originals. Yeah, okay, cool.
I think an HDMI proper screen would be better.
Alright, we will definitely play with the FPGAs and the little Pico arcades.
So you said now the Lego project is FPGA Pac-Man.
That's an awesome idea. That's what we hope for.
I got a screen from Chime actually.
We already have a willing workshop attendee. So the last segment, we will very quickly go through the hirings and anybody looking for a job and related events. Anybody hiring for electronics engineering or DSP? You can have your announcements here. Nobody hiring. Okay. Or looking for a job? Okay, nobody. Any related yes, Martin.
The DARPA, which is the US defense
Yes.
guys who did this huge robotic humanoid robotics, they've got a program called the RFT, or essentially it's for hackerish kind of people to have ideas. And basically, normally they've been funding like $5 million for Lockheed or just very big projects. They want to give it out in units of like $50,000 or $100,000. People who have smart ideas, and basically they have you can go on their website and it's like, please fill in the form and we'll get back to you in 30 days, yes or no.
Right.
And so they don't have very high standards in terms of got to fill out all this paperwork. They want to see lots of little projects and just see what happens. And I've got kind of some ideas about little robot projects to do, but that seems like an interesting little thing.
So if anybody wants to join Martin?
Oh no, I'm just saying in general, this is a very interesting kind of thing from the US government. The license that they have is you have to make it available for free to them, but you own the IP afterwards. So it's kind of an interesting gamble like that, right? They just feel that outside of smart people at Lockheed, there's a lot more hackerish kind of stuff. It's really interesting.
So a quick add-on to that. A few Hackwares ago, Michal showed out the HackRF, which was a what do you call, like a software-defined radio.
Yeah.
That was actually created under one of DARPA's fast-track programs. And the cool thing is, it's completely open source, and DARPA was really fine with it. So they just gave money to this guy to create this completely open source software-defined radio. So just to keep that in mind, it doesn't have to be like military stuff. It can be very interesting hackerish things.
Right. And it doesn't have to be in the US at all.
Yeah.
It's not basically.
All right. Yes.
Yeah. Thanks. I got an event to announce.
Yes. Absolutely.
I'm actually from the NUS Enterprise Development Lab. Okay. We have this interesting event tomorrow, which I think is quite relevant for you. We have this team that has this technology that's able to transmit data or even a movie just via LED lights. So it's in such a sense, it's like they have an LED light in the middle of the room, and then laptops all over around the lights, and just by the light alone, it can actually transmit HD movie. So I think it's something that you all can incorporate into the chips. And sorry, I'm quite a layman, but this is what they are able to achieve. So the meetup is actually tomorrow. Then they have actually experts that deals with this. They'll be there to share with everybody how you all can use this technology to actually use it in your project. Yeah.
What time and where?
Okay, it's actually in NUS Tech Hub. The time is 6:30.
Yeah, maybe you can tell him.
Yeah, because I used to put it on the meetup.com events, right? Which Chime will be able to pick up. But because of some data security issues, NUS doesn't
So it's
allow
a
us.
privately listed.
We have another sign up link. What I can do is maybe later I'll have a pen and paper.
Maybe you can talk
just
to
come to
him.
me, give me your email, and tonight I'll send you the link so you all can just go in and
Awesome.
post it on the Hackware group. Or if it's allowed, Chime is okay, I can just put the link on meetup.com, this group, and then you all can just click in. Thank you so much.
Absolutely, absolutely. Just put the link there or just talk to him after this. Any other events? Yeah. So,
do you want to
Notebots.
announce the notebots?
Yes.
Yes, so I want to say that if you're looking for any open, free, engineering related events, you can go here. So we query by Facebook API and meetup.com API. So it happens every hour. So if your event, or even Eventbrite, so every hour this list is updated. So I want to point out 2 events. One of them is happening, so you can check by date as well. One of them is happening this Saturday, and that is related to some of you, and it's called the Node Bots. So maybe Martin or Chinmay can talk a little bit about Node Bots.
So Node Bots it's an international Node Bots day. So basically, all over the world, people gather to play with robotics and sort of use Node.js to control smaller robots. This is our effort to start the Node Bots thingy in Singapore. So it's a little bit rushed and it's a little bit last moment. So we don't have all the kits and stuff perfectly ready yet. But if you want to come down, it's going to be downstairs, exactly this location, just downstairs. We'll have some desks set up. If you have your own Arduinos, it's based on Arduinos. If you have your own Arduinos, please bring them down. We will have 12 gigs selling some components and some kits, hopefully, if they arrive in Singapore on time. But otherwise, it's just going to be basically controlling Arduino using Node.js and then putting some servo motors on it, making it move around. So it's very simple. It's going to be more sort of learning together rather than
The target audience does not need to have software or hardware background, right? Maybe you can have a little bit of JavaScript.
No, not in this one. It's good to have because it's so there isn't a very so we don't have like a very proper setup yet this year. Maybe next year we will. So if you have played with this stuff, bring it down. We'll have more fun with it. You don't actually know. You do. We will use some JavaScript, but if you and it will be good if you know some JavaScript, but it's not that hard. It will be very basic JavaScript, you know, like LED.on kind of stuff, right? Like not that complicated. So don't worry about that much.
All right, and the last event that I have is on 30th July, and that is amateur radio. Roland is not here. Neither is I'm definitely
promised to come tomorrow.
Yeah, he's not in Singapore. Is the Liu here? No. All right. I'm definitely not the person to talk about it, but Singapore has an amateur radio group. You know, they operate the ham radios. You can have a license and then do some cool stuff like moon bouncing or like bouncing off and build your own antennas. So if you wanna join the meetup, it's on this day, and that's the website. Any other related events anybody wants to point out?
I would have a query.
Yes.
So if because I got a signal that hardware is a problem, that we have the uniform hardware for the workshop. So if there will be basically people that are willing to register on this basis, we can basically get together like 10 people and buy something like this with the shield so that we have the same device for the workshop, and we make sure that everything is identical so nobody has problems with setting it up.
All right, if not, please, sorry? Next Hackware will be in August, Hackware 1.0, that's like what?
I said 0.11.
No, 1.0 semantic versioning.
0.10.
We are going binary, is it? Semantic versioning, okay. So it will be in August.
We are still looking for location.
We are still looking for location. We would love to try out academic institutions or hint hint.
So basically, any space that can sort of hold this group, if you're willing to sponsor your location, talk to us. We'll.
If not, of course, we will fall back to Hackerspace. But
we are kind of outgrowing Hackerspace. So
yeah, right. The group is like. Otherwise, 1 month from now, you'll have Notebots, Amateur Radio, FPGA group. So have fun.
Hackware is the last Wednesday.
Last Wednesday of every month. All right, not 4th. Last Wednesday, because sometimes months have 5 weeks. So if not, please stay back and mingle with one another, play with the hardware, and we will see you next month in August. Thank you.